6.3 polar coordinates. In this section is what we're really going to do is we're going to be graphing points and graphing curves in a new coordinate system, okay, called polar coordinates. The coordinate system that we're used to is called Cartesian coordinates, or sometimes also called rectangular coordinates. And by switching to this different coordinate system, we'll actually be able to simplify certain types of problems and make them easier to solve when we're in physics and calculus. But what I'd like us to do first is just look at the graph of a polar function. Okay, and the reason I'd like us to do this is the graphs are pretty interesting. Okay, so let's go ahead and do that real quick before we actually jump into the details here. Now that we have our calculator in front of us, let's go ahead and hit the mode button and make sure you're in radians. And the only other thing I want you to go down here and change is you can see right now I have it blinking over function. So your calculator up to this point has probably always been in function mode, but you have a few other modes here, one of which is parametric, which we'll talk about later in the quarter. And the one that we're about to talk about now is polar. So let's go ahead and hit enter here. And we'll go ahead and we'll hit y equals. But you can see this is no longer a y equals menu. And that's because when we are in Cartesian coordinates, we like it to be y equals. But when we're in polar, we're going to like it to be r equals something. And before we actually type in an equation here, let's adjust our windows a little bit. So you can actually already see for theta min and theta max, which we don't quite know what that is right now, but I'll just tell you it's an angle. And we're going to let this angle theta vary from 0 to 2 pi. And a theta step of 0.1 should be plenty here. This is just our spacing with our theta values with each point that we plot. And then next we have our x min and x max, and a y min and y max. Let's actually go ahead and just leave those as -5 to 5 by 1s. And now that we have that window filled out, let's go ahead and go into the y equals, and we'll actually pick a function here. Let's do 4 sine, and it surprisingly has already plotted something even though we haven't typed anything in here. 4 sine, and then let's say 7 and theta. So if you hit the X button when you're in polar coordinates, it brings up theta instead of X, because our variables that we're going to be working with in polar are going to be r and theta. So I'll just put a close parenthesis here, and let's go ahead and hit graph. So you may have actually noticed it sketched out a shape here 2 times. It did it kind of quick. But you can also see it's looking a little bit rigid here. Okay, this doesn't look very smooth, and that was because our theta. Let me go into the window here so you can see it. Our theta step was 0.1. If we go a little bit smaller, we can smooth this out a little bit. So let's maybe try 0.05. And let's do another thing. Since it seemed to have traced this shape out twice in 0 to 2 pi, let's maybe try and just do 0 to pi here. So I'm going to move back up, and my theta again is going to go 0 to pi instead. We didn't need the 2 pi. Let's go ahead and hit graph. And there it is, looking a little bit smoother. And we could try a few other things out here. We could try maybe this thing here, maybe -3. Let's see what that looks like. And so we can get all sorts of neat shapes here when we're in polar coordinates. Okay, and again, because it's easier to plot these things that are really curvy, okay, it's going to end up that being in polar coordinates can simplify some of the problems that we solve later on, again, in calculus and in physics. And in fact, there's even a 3D version of polar coordinates. And I would almost say that there's two of them. They're called cylindrical and spherical coordinates. And again, both of those you will learn in calculus. Let's go ahead and go back to OneNote and actually figure out what on earth polar coordinates are. Now that we're back in OneNote, you can see 2 points plotted here, x comma y and r comma theta. But if you look carefully, you'll notice that they're in the exact same location. Now, I've drawn some yellow lines on here, so these pictures might look a little bit different, but those points are in the same spot. Okay. Let's start off thinking about the one in Cartesian coordinates. This is the coordinate system that we're used to, and probably the only one that we know as of right now. And all x comma y means is that we went over x units in this direction, the horizontal direction, and we went up or down y units in the vertical direction. Now, if we're in polar coordinates, the question is, well, what's the difference? Well, the difference is when we describe a point, we're not describing how far we're going in the x and the y direction. One thing we're going to use to describe our point is just how far it is from the origin. So I'll put an r here. Okay. That's all that r means, is we're r units from the origin. And the only other thing is theta, and that is the angle here off of the positive x-axis. Just like when we're thinking about our trig functions, right? How we define them using the unit circle. We always measure that angle theta off the positive x-axis, and we're going to do the same thing here. And so we'll go ahead and we'll just fill this in. The point, r comma theta, in polar coordinates is described by a ray of length r and an angle theta measured from the positive x-axis.